Okay, this first page of the notes, we are going to look at graphing exponentials. An exponential form has this general form of the equation. You'll notice that we have the h and the k in this form, and it'll behave the same way as the h and k in the other equations that we've worked with. Every exponential function will have a horizontal asymptote that will actually pass through that hk. The hk is not actually on the curve of the exponential function, it's just the point where the asymptote will pass through it. A few other things that we notice about the equation is if the c value in our standard form is positive and the a value, that ratio, is more than 1, the graph is referred to as a growth function. If the c value is positive and the a value, the ratio, is less than 1, the graph is considered a decay function. Depending on the course, if the c value is negative, sometimes they will refer to it as a reflected growth or a reflected decay, but it depends on the class. The inverse of an exponential is, of course, a logarithmic graph and will be a reflection over the line y equals x. We saw earlier in the chapter that inverses are always reflections over this line. We can easily find it just as we did at the beginning of the chapter by reversing the points, and that simply means that we're going to switch the x and y. So if we want to start graphing one of our exponential functions, the first thing that we're going to do is we're going to identify what our hk is, because it will help us find our asymptote and get that on the graph right away. So if I want to find my hk, I simply look to the exponent here to find 2, remembering that it's written in that negative notation, so we do flip the sign, and then we're going to have a negative 8. So it never hurts to go ahead and just plot that point to negative 8 and understand that it will have a horizontal asymptote through it. The other things that we can do before we jump into actually calculating points is we should realize that we can always calculate our x and our y-intercepts. So if I let x equal 0, that's going to allow me to find my y-intercept. So I'm just plugging into my equation. So I have y equals 2 times 3 to the negative 2 minus 8. From there, I'm just going to evaluate, just do my arithmetic. 3 to the negative 2 is 9, so I'm really just going to have 2 over 9 minus 8. I recognize that since I'm going to subtract these fractions, I'm going to need to get common denominators. So I can get my y value of negative 70 over 9. I'll write that as an ordered pair when we get to the bottom of the page. I can also find my x-intercept by letting y equal 0. So I have 0 equals 2 times 3 to the x minus 2 minus 8. So if I'm just going to solve this simple exponential, add my 8 to both sides, divide by my 2. There's no way that I can get these two bases to match, so I'm going to just switch to my logarithmic form. So I'm going to have log base 3 of 4 equals x minus 2. So x equals a positive 2 plus log base 3 of 4. So again, I can take both of these and I can write them as ordered pairs. I can also write the equation for my asymptote down here. The asymptote has to be the equation of a line, so it's going to be our y equals negative 8. My y-intercept from up above, I'm going to say 0 and then negative 70 over 9. And my x-intercept is going to be 2 plus log base 3 of 4 and then comma 0. If I had the benefit of a calculator, I could certainly type this in and get a decimal approximation for that. Now, when I come up here and I make my t-chart for my actual graph, my goal of this t-chart is to create what I call a smart t-chart so that I don't actually need a calculator. So I'm going to set up my t-chart here. And when you're making a smart t-chart, it's easier to think of it from the right hand, starting with your y values. What do you want that y value to look like? So if I'm looking at this exponential, what I know is that it's easier to calculate values when my exponents are either 0 or 1. So that's the first thing that I'm going to think about. What if I could evaluate this and have 2 times 3 to the 0 power minus 8? I know that 3 to the 0 power is simply 1, so I really just have 2 minus 8, or negative 6. I can also do 2 times 3 to the first power minus 8. So that simply gives me 3 to the first, which is 3 times 2 is 6. 6 minus 8 is negative 2. So once I know what my values on the y side of my t-chart should be, I'm going to work backwards and think, how can I get those? I wanted my exponent to be 0, but my actual exponent is an x minus 2. So I'm going to solve a little mini equation, setting the actual exponent to what I want it to be. So that tells me that my x-coordinate for this point should be 2. So now I have a good ordered pair. On my next one, my actual exponent is x minus 2. I want it to equal 1. Again, just solve the little mini equation, and I get 3. So now I have 2 very nice points that I can plot. So I have 2, negative 6. I notice that it's closely aligned with my original HK point, and I have 3, negative 2. Now, although these 2 points might look linear, I have to understand that an exponential graph should be growing quickly and then should come down and approach the asymptote. So that's our exponential graph. And then the last little bit that we want to do is we want to go ahead and take a look at how we could graph the inverse very quickly. If we understand our inverses, and that the inverse should be a logarithm, all we have to do is flip the x and y on everything we've already done, which means our asymptote is now going to be x equals negative 8 instead of y equals negative 8. I can even flip the original HK point that was to negative 8 and plot it as a negative 8 up 2. I can take the t-chart that I just calculated, and if I want to write it out, I can do that as well. And I can rewrite it as negative 6, 2, and negative 2, 3. So if I plot those points, I can now see that my logarithmic graph is going to flatten out and will drop quickly and approach its asymptote. What I can see and remember from my original understanding and studying of inverses is that sure enough, those 2 graphs do appear to be reflections over the line y equals x. At the bottom of the page, we can now finish answering all of our questions. For the exponential graph, I can see that my domain is all real numbers. That makes sense because it doesn't matter what value I put into the exponent. So I can say negative infinity to positive infinity. However, I can see that my range begins just slightly above 8. I can't include that negative 8, so it goes to positive infinity. So negative 8 to positive infinity, not inclusive on either end. For the logarithm, I don't have to do any math to find all of these things. The asymptote, as we already saw, is just going to be x equals negative 8 instead. I can find the y-intercept by taking my original x-intercept and reversing it. I can find my x-intercept by taking my original y and again reversing it. My original domain becomes my new range, and if we look at the graph, that makes sense. My range for my logarithmic graph is negative infinity to positive infinity, and I can flip the domain as well. Negative 8 to positive infinity. And that's everything that I need for an exponential graph and its inverse.